What do you want from me? Why don't you run from me? What are you wondering? What do you know? Why aren't you scared of me? Why don't you call me?
Thank you very much, Zippy. Good evening. My name is Sergeant Cecilia Silliphant, and welcome to Vintage Key Studio. Today, I am showing you the RCA Beat Frequency Oscillator number 154. This oscillator dates from 1938 and is an American model, so it runs at 110 volts. I bought this a few years ago with a view to using it as a musical instrument. As of today, it is still just in its oscillator form, as in just the box with a dial on the front. But I'm hoping in my next video to be able to show you an adapter that I'm going to make, which will allow me to play it with a slight bit more accuracy. Let me just explain the general idea of how a beat frequency oscillator works. You have two oscillators. One of them is running at a very high frequency with a fixed pitch, and then the other oscillator has got a variable pitch. It happens in musical notes, like when you're tuning a guitar. If you play the same note together and then gradually detune or tune up one of them, you get what's known as beats between them. So a bit like this. So on this acoustic bass, you can hear I've got the two lower strings tuned to D or thereabouts. And then if I gradually move them, you can hear the beats between the two notes get faster. And then as it goes back up to the... There we go. So it's in tune with itself now, and the oscillations are very, very slow. So I'll just do that again. So you can hear they're getting faster there. Very fast. So the natural occurrence of beats is how for instance, a piano tuner will tune a piano and they listen out for the beats between the two notes, and it's just your ear picks up on this kind of like woo, 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 sort of interaction between two frequencies. So it's exactly the same idea in this thing. The difference is both oscillators are oscillating at a really high frequency that we couldn't hear. But what happens is the two oscillations, when they're joined together, create beats, which are then, in this thing, they are then amplified, those beats, into a sound that we can hear. If I just play you what it sounds like coming through here, this is the sum of the two beats together. So you can hear that the range of this thing goes below and above human hearing. If you actually look on the schematic of this, the range of there's a thing inside called an air capacitor or variable capacitor, which you will see a picture of now, which has basically got teeth that interlock. So the capacitance is greater, I think, when they're locked and less when it's apart. The actual range between when it's apart and when it's open here is a tiny, tiny amount. It's like about 30 picofarads, which is a tiny amount of capacitance, compared to on another oscillator I've got, which is not a beat frequency oscillator, which uses a 1 megohm resistance, which is quite a large resistance. So here we have the beat frequency oscillator with a tiny, tiny capacitance that is producing this huge difference in pitch. Because of the fact that the beats in between the two little oscillators that are running at very high frequencies are changing minusculely, but the beats added together, when they're amplified, sound like this to us, which is quite useful. The beat frequency oscillator circuit was used famously in the Theremin and the Ondes Martenot keyboard and slidey thing, and also it is used in a metal detector as well. So you might sort of be going along one day and hear this sound. And that'll be somebody with a metal detector finding a very, very valuable coin. But you're not allowed to keep it. Now this thing I've modified ever so slightly because it has an output. These are the outputs of the oscillator that you should use, but I've modified it so it comes out at the sort of nominal line level output, and I've put a line out in the back here. And this thing's basically power on, power off. You've got the output level, the indicator, which is meant for sort of adjusting the calibration. So if I move that, you can see that this is showing the rate of the beats, and where it's got like a tuning capacitor on the end of this one. And if you can hear it, that actually reduces the range, and then you can move it right down, and then that increases the range like that. So it's very useful, but pretty hard to play as an instrument. I've got it linked up through this little volume pedal on the floor here, just something quick. It's not really particularly efficient, but it's okay. And you can kind of get a sort of a Ondes Martenot type. And if you wiggle the dial, you get a bit of vibrato. But it's exhausting doing that. And also, the knob comes off sometimes because the grub screws come undone. So I'll just do that up. Okay. You can also see on here as well that the knob that I'm turning there is going round at a different rate to the indicator there. And there's like a geared system inside there, a few cogs in there to do that, because otherwise if you just had it like that, it would be even harder to control the in between the notes. And obviously this isn't designed as a musical instrument, it's designed to kind of create a tone to test something with. It was also designed as part of an old-fashioned radio system as well, for testing, and for some aspects of old radios had these in as well, I think. Now, don't try this at home or work. I've taken the casing off this, and just to demonstrate that this thing has the similar properties to the Theremin, if you look here, if I just turn this up a bit, if I get part of my body dangerously close to this earth lead here, which is actually okay because it is earth, but you can hear that by just moving my hand through the air near that wire, and it's disrupting the capacitance going through there. So it's a similar sort of situation to, say, a metal detector or a Theremin. But I won't do that too much because it's not very good for you if you get killed. So there we have a brief rundown of what the Beat Frequency Oscillator does. Pretty much it just goes ooh, but very useful. I've used it on quite a few recordings. I'm hoping that in my next video, when I've made this little adapter, it'll enable me to play the notes in a more musical and easier way. But the good thing about this is, compared to the Ondomo slider that I made, that is still working with sets of octaves. So you've got there's 4 different octave selectors on that. So you've got the distance from between there and there on the slider is only sort of about 3 octaves worth. Whereas this the distance between there and there will be the entire range. Or the difference between here and here, which is probably better. But I'm gonna experiment with it and try and get the right size. And then hopefully next time, or maybe not exactly next time, but very soon, I will have the miraculous Beat Frequency Oscillator adapter, which will look just like one of those old VHS things you used to get for videos. You put the little one from the video camera in, and there was a big one, then you stick it in the machine and it gets jammed. I must stress, please do not stick your fingers into old equipment like this when it's switched on, unless you're me, but even then don't do it. And I will leave you with a rendition of Good Night.